So, good day, welcome to today's class. In today's class, we will continue with differentiation. As you know, we have some other videos on differentiation. This is just differentiation 3. We're using general method and we're doing some other things. So, if you are going to watch out for the first and the second video, I'll drop the link under this particular video. Watch that out before you come here. And if this is your first time on this channel, do well to click the subscription button so that when we drop more educative videos, you get notified and be the first to have access to it. So now let's go. In our last class, we discussed about differentiation, introduction to differentiation. We talked about so many things. And I discussed the first principle with you and the general method. I put the formula for general method, how to do that. But today we'll be solving some questions using the general method. And we'll be looking at differentiation rule. Now, imagine you are given a question like this: y equals to 2x cubed plus 3x minus 5. And they said, find the y dx. That means differentiate this function, differentiate this equation. How do you go about it? Now, solution. You have y to be equals to 2x cubed plus 3x minus 5. Now, what do you do if you want to differentiate? So, you want to find the y dx. Don't forget that I said it is the same thing as theta y over theta x. They actually mean absolutely the same thing. But in first principle, we use this the most. Why in general method, we use this the most. Don't get it confused. They actually mean the same thing. So, the y dx will be equals to. Now, what is the power of the variable here? 3, of course. Now, you bring this 3, you multiply it by the 2. Bring the 3, multiply it by the 2. Then you subtract 1 from the power. This is how you always do. If you have n raised to power n, you bring this you multiply it by, there's 1 at the front of this x. So n times 1, that is n x, and you subtract 1 from n raised to power n minus 1. So that is just the application. That is the ideology behind it. So here you come here, you say 3, you multiply by 2. That is 6 x raised to power 3 minus 1. That's what you do. Plus, now this x is raised to power 1. I don't even have to tell you that anything that doesn't have power is always raised to power 1. Plus, now you bring this 1 again, you multiply by 3. 3x raised to power 1 minus 1. Right? Now minus 5. This 5 here doesn't have anything, doesn't have x. Normally, some people will tell you that whenever you are differentiating a constant, you have 0. But let me tell you why it's 0. You know, this 5 doesn't have any x, so it has 0x, right? So we say 5x raised to power 0. Now let's differentiate. Let's do separately. Because we differentiate minus 5 or 5, any constant, you always get 0. Now we want to differentiate 5 using the same procedure. It doesn't have, sorry, this 5 doesn't have 5 here, doesn't have a variable beside it, right? So we just assume that let's give it 0 because it has nothing, that's no x. So let's say it's 0. So let's differentiate now. 0 multiplied by 5, that's 0. 0 times x, that's 0. So that's why whenever you're differentiating a constant, a single number without any variable or anything, you always get 0. Have that back of your mind. So you know when we differentiate this minus 5, we have 0. So leave that out of the equation. So my dy dx will now be equals to 6x raised to power 3 minus 1 is 2 plus, now 3x 1 minus 1 is 0. And don't forget that n raised to power 0 is 1. So we have my dy over dx will be equals to 6x squared plus x raised to power 0 is 1. Anything raised to power 0 is 1. So 3 times 1, 3. This will be my final answer. Now, quickly, let me prove to you why x raised to the power 0 is 1, or why is any number raised to the power 0, why is it 1? 5 raised to the power 0 is 1, 10 raised to the power 0 is 1, any number raised to the power 0 is always 1. Why is it like that? Let me quickly prove that. It's not part of this video, but I'll teach you that. Now consider this set of numbers. 1, 2, 3, 4, 5. Should I? Yeah, sorry. Let me consider this set of numbers. 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, then it's not here 2 raised to the power 5. Now, we want to know why 2 raised to the power 0 is 1. Right? Why is it 1? Why is it always 1? Any 2 raised to the power 0, why is it always 1? Let's look. 2 raised to the power 1 is 2. We all know that. 2 raised to the power 2, that's 2 times 2. We have 4. 2 raised to the power 3, 2 times 2 times 2, we have 8. This we have 16, this we have 32. Now in mathematics, one of the things we do is we observe numbers, we observe changes in numbers. Let's observe how these numbers are changing. If you observe that something, you see that if I divide this 32 by 2, I will get 16. Is that not true? If I divide this by 2, I will get 16. If I divide this by 2, I will get 48. If I divide it by 2, I will get 4. If I divide this by 2, I will get what? 2. If I divide 2 by 2, what will I get? 1. So that is why anything raised to the power 0 is always 1. Anything raised to the power 0 is always 1. Because when you observe the changes, 2 divided by 2 is not 0. So it's 1. That's why 2 raised to the power 0 is 1. Take note of that. Anything raised to the power 0. That is the reason why anything raised to the power 0 is 1. So that's not all about that. That's just by the way. So I hope you get this very, very well. Let's have another illustration. Imagine we have y to be equals to y to be equals to x raised to the power minus 3. X raised to the power minus 3. Now, in this situation, what do we have to do? We still follow the same process. We just say the y over the x is equals to, what is the power of x? Of course, it is minus 3. Bring it to the front. Minus 3. Don't forget that you subtract 1 from the power. X raised to the power minus 3 minus 1. Then you have the y, the x will be equals to minus 3 x raised to the power minus 3 minus 1. That is minus 4. That's your final answer. Number 3. What if you have something like this? Y equals to 1 over x. Find the y, the x. This is the general method. This is where your idea of indices plays in. This y, I can write this as x raised to the power minus 1. If you know your law of indices very, very well, there's a law that states this. Now, if I write it as x raised to the power minus 1, then I will differentiate the y over the x will be equals to minus 1, bring it here, then minus 1x, that's minus x, raised to the power minus 1, then subtract 1, minus 1. Then the y, the x, equals to minus x raised to the power minus 1 minus 1 is minus 2. And we have the last example under general method. We have y to be equals to 6x cubed minus 4x squared. Find the y, the x. Same procedure. The y, the x will be equals to 3 multiplied by 6, that's 18 x raised to the power 3 minus 1, that is 2. Minus 2 multiplied by 4, that is 8 x raised to the power 2 minus 1, then 1. Then this will be your final answer. So, I hope you understand. I hope you now understand how to use general method very, very well. It's very simple and very fast and very straightforward. But you need to know the first principle also, because in some examiners might request first principle from you instead of this general method. So let's proceed. Let's go on to the rules of differentiation. Let's look at what rules guides differentiation. The chain rule, the product rule, the quotient rule. Let's look at them. Now, welcome back to the class. Here we have chain rule. Yeah. Chain rule. Now imagine a question like this. You are given y equals to 3x minus 4 raised to the power 3 over 2. No, literally you cannot expand this bracket because it's having fraction. How do you want to expand the bracket that is having fraction? Then that is where your knowledge of manipulation comes in, because mathematics is about manipulation. But you know how to dive your way from this topic to enter this and lead it to this. That is how God make mathematics very, very, very simple. You have to understand the concept. Now, I know very well that I cannot expand this bracket, right? So I will say let u be equals to 3x minus 4. Now in chain rule, whenever solutions, you are given questions like this and solve directly is not possible, you always represent the given variables, you always tend them to be another variables. What do I mean by that? I cannot expand this, so I will say let u be equals to 3x minus 4. So that anywhere I see 3x minus 4, I will put u. But before I put that, I need to differentiate this. You know, this is du dx. You differentiate this one with respect to this. You differentiate this one with respect to this. When I give you y equals to 3x, you say dy dx. Y comes first, then x. So this one will be du, because u comes first, then x. So you have du dx is equals to, when you differentiate this, when you differentiate 3x using general method, you have 3. Right? Now leave this like this, circle it. Now, look when I said that let u be equals to 3x minus 4. So that we have y equals to, anywhere I see 3x minus 4, I can put u raised to the power what? 3 over 2. Let me find dy du. So when you replace u with a variable, or you replace any alphabet with a variable to differentiate, you still change the name and differentiate. When I represent u to 3x minus 4, I differentiate. And when I put u back in the equation, I still differentiate. So differentiating this, you have dy du to be equals to 3 over 2, yes, because 3 over 2 bring it in, multiply by u raised to the power 3 over 2 minus 1. 3 over 2 minus 1, that gives 1 over 2. So that will be equals to 3u over 2 raised to the power 1 over 2. Don't be confused. 3 times u, 3 over 2 minus 1, 3 raised to the power 1 over 2. Everything over 2. Don't forget that what I was told to find is find dy dx. Second case also, because we are going to read it. They said we should find dy dx, not du dx, no dy du. Now how do we find dy dx? You can simply say that dy dx is equals to dy du times du dx. du dx. I will explain why. This is what we call chain rule. I will explain why. You know, if I have 3 over 2 will be equals to 3 over 4 times 4 over 2. Yes, let's do this way. 3 over 2 is equals to 3 over 4 times 4 over 2. I can simply say this 4 cancel this 4, right? Because they are the same thing. So that we have 3 over 2 to be equal to 3 over 2. Because 3 times 1 3, 2 times 1 2. Now when I look at this, I have du here, just like I have 4 here. I can simply say let du cancel du. So I'm left with dy dx. That is the ideology behind chain rule. So now let me say thing. So dy dx is equals to dy du times du dx. What's my dy du? Dy du is 3u raised to the power 1 over 2 over 2. 3u raised to the power 1 over 2, everything over 2, times what's my du dx? Du dx is 3. Du dx is 3. So let's go. 3 times 3, I have 9. That will be 9u raised to the power 1 over 2 over 2. But don't forget that in the question, we were not given u. But in the question, we said our u is what? 3x minus 4. So anywhere I see u, I'll change it to 3x minus 4. So my final answer will now be 9, open bracket, u is 3x minus 4. 3x minus 4 raised to the power what? 1 over 2. Everything over 2. And this should be my final answer. The final answer. Let's try another example. Let's see how it goes. Now, here we are again, still on table. Example 2. We have a question like this: y equals to 2x squared plus 3, everything raised to the power 5 over 3. You know very well that you cannot expand this, so you use chain rule. So what do you do? The same procedure. Let u be equals to everything inside this bracket 2x squared plus 3. Then I'll find du dx. Du over dx is equals to 2 times 2, 4, general method now. Then x raised to the power 2 minus 1, which is 16 minus 4x. Plus this 3, the differential, you know, is a constant and you get 0. So leave this like this. Replace this, you have your y to be equals to, I said this to be u, right? So u raised to the power 5 over 3. So you find dy du. So my dy du equals to 5 over 3 u raised to the power 2 over 3. Yeah. Yes. So 5 over 3 u raised to the power 2 over 3. I can write that by saying 5 u raised to the power 2 over 3 over 3. So this is my dy du. My dy. So using chain rule, dy dx is equals to dy du times du dx. What's my dy du? My dy du is simply 5 u raised to the power 2 over 3 over 3. Now dy du 5 u raised to the power 2 over 3 over 3 multiplied by du dx 4x. Now we have 5 times 4x. We have 20x u raised to the power 2 over 3. But I'm not dealing with u. I have to change my u to 2x squared plus 3. So we have 20x into bracket 2x squared plus 3. Everything over 3. Then this will be my u raised to the power 2 over 3. Yes. So this is my final answer for chain rule. So let's move to product rule. Let's see how it works. Now welcome back. Now we have the question on product rule. Sorry for that. The question on product rule. We have, okay, firstly, when do we use product rule? Whenever you hear the word product in mathematics, product simply means multiplication. Product simply means what? Multiplication. So, in any situation whereby we have two variables being multiplicated, we use product rule. What does product rule state? Product rule state that v du dx plus u dv dx. This is product rule. V du dx plus u dv dx. This is the product. Whenever we have multiplications, look at this question. We have 2x square root of 1 over 2 multiplied by x plus 3. If you had had something like this, 2x open bracket x plus 3, we can easily expand. We just have 2x squared plus 6x and we differentiate. But in this situation, you cannot differentiate. Why? Because we cannot. To expand will give you issue. Because this one is having a power of 1 over 2. It is just best for you to just use product rule. In a situation like this, you can use product rule. You can decide to expand anything you wish. But whenever you have complex questions like this, it is more advisable to use product rule because in some situation, you might not be able to expand or expanding might take you more time. That's when we use product rule. When two things or two variables or two digits with variables are being multiplied together. So let's do. From this one now, what do we see? We use two alphabets majorly in differentiation, and that is U and V. U comes before V. So anyone that comes first will be your U, then the latter one will be your V. Out of these two, which one comes first? Obviously this. So let this be U. Let this be V. And don't forget that whenever you are replacing, you are differentiating. So, like I said, let my U be equal to 2x raised to the power 1 over 2. Right? Okay, let me differentiate. When I differentiate, I will have the U dx is equal to. Now, this power multiplied by this, that's 1 over 2 multiplied by 2x. Just use the general method. When you differentiate, you have 1 over 2 multiplied by 2x raised to the power 1 over 2 minus 1. General method. I've explained that earlier. So we have du dx is equal to 1 over 2 multiplied by 2. That is 1. So you have x raised to the power 1 over 2 minus 1. That is minus 1 over 2. That's simply the process to do. So general method, you apply that and you have a final answer. Now, this is du dx. Let's keep this aside. Now, let's move to V. My V is equal to x plus 3. So I will say the V dx will be equal to, if you differentiate this, general method, you have 1. Then, you differentiated this. So what's the next thing? Is to use your formula. Let's go. V du dx plus u dv dx. What's my V? My V is what? X plus 3. I need x plus 3. Multiplied by what? Du dx. What's my du dx? My du dx is x raised to the power minus 1 over 2. X raised to the power minus 1 over 2. Plus, what is my u? My u is 2x raised to the power 1 over 2. 2x raised to the power 1 over 2. Then what is my dv dx? My dv dx is 1. 1. Then you can multiply this, so you have x plus 3 into bracket x raised to the power minus 1 over 2 plus 2x raised to the power 1 over. Then this will be your final answer. Let's have another question on product rule, or we proceed to quotient rule. So, welcome back. Another question on product rule. We are using the same process and the same procedure. So, we just say, let this one be U, let this one be V. So, you say, my U is equal to square root of x. We all know that this square root of x, I can write it as x raised to the power 1 over 2. So my du, my dx is equal to x over 2 raised to the power minus 1 over 2. If you differentiate this in general, this is what you will have here. Exactly. So you keep this aside. Then you come to this again. My v is equal to x plus 2. Then you find dv dx. Dv dx, when you differentiate this general method, you have 1. Then using product rule, v du dx plus u dv dx. What is my v? My v is x plus 2. X plus 2 du dx. Du dx is x over 2 raised to the power minus 1 over 2. X raised to the power minus 1 over 2 over 2. Plus, what is my u? My u is square root of x. Square root of x. dv dx. Sorry, dv dx exactly. dv dx is 1. So 1 times this is this. This is my final answer. Let's see what quotient rule entails. Then maybe in our next class, we'll solving more complex questions. Questions that combines with chain rule, product rule, and quotient rule. Let's solve quotient rule first. Let's see. Welcome back. Now, in quotient rule, I said that product rule I said product rule deals with multiplication. But quotient rule deals with division. Anytime you have differentiation question in divisional form, if you can't solve further or you find it difficult, you are advised to use quotient rule. What does this quotient rule state? Maybe in one of our videos, I will make videos and prove how we get all these formulas for you if it is required. So the product quotient rule states that v du dx minus u dv dx over v squared. This is quotient rule. Quotient rule. V du dx minus u dv dx over v squared. Now, using this formula, let's solve this. My question is y equals to x plus 3 over x minus 2. I told you earlier that the one that comes first we take 0 because u comes before v, and the latter one we take v. So let my u, this be my u because it comes first, and let this be my v. So if my u is equals to x plus 3, then du dx is equals to 1. And if my v is equals to x, sorry, this is meant to be 2. Sorry, this will be 2 here. So if my v is equals to 2x minus 2, then you circle this. So dv dx is equals to 2. Then let's use our quotient rule. Our quotient rule v du dx and u dv dx over v squared. What's my v? My v is 2x minus 2. 2x minus 2 multiplied by du dx. Du dx is 1 minus, what is my u? My u is x plus 3. X plus 3 multiplied by dv dx. dv dx is 2 over, what is my v? V squared. 2x minus 2. Sorry, 2x minus 2 squared. Then this is my final answer. You can proceed to expand, open this, expand this. Well, I'll present my answer in this format. This is my final answer. Let's solve one question on quotient rule. Let's see what it entails. Now, here is another question. Y equals to this over this. Find dy dx. This is a division question of differentiation. It's better for me to just use quotient rule. So I'll say this is my u, I'll say this is my v. So let's move. If my u is equals to x squared plus 3x minus 4, then my du dx will equals to, differentiating this, 2x plus 3. Then you leave this aside. Leave that aside. Then you come to this. My v is equals to 3x plus 6. So the v dx is equals to 3. Leave this. Then the formula for differentiation, for quotient rule, v du dx minus u dv dx over v squared. What is my v from the question? My v is 3x plus 6. 3x plus 6 multiplied by du dx. Du dx is 2x plus 3. 2x plus 3 minus, what is my u? Sorry, this is my u. My u is x squared plus 3x minus 4 multiplied by what? Dv dx. Dv dx is 3. Everything over v squared. Formula, sorry, okay, v squared, yes. So 3x plus 6 squared. And this will be my final answer. So you have come to the end of today's class. Please don't forget to like, comment, and subscribe. If you have anything, any opinion about the video, please see the comment section. We're going to reply. So click on the subscription button again so that when we drop new videos, you'll be notified about it. Thank you. In our next class, sorry, before I end class, in our next class, we're dealing with questions that combine product rule, quotient rule, and chain rule together. Sometimes 2, sometimes 3. We're not going to given straight and simple questions like this. We might be given questions like that. So we solve that. Then after that, we now move to the applications of differentiation. Why is differentiation introduced into business? Why? Because it has some relevance. So we're going to look at this relevance and in some other classes. Thank you. If you know you love this video, like the comment section. See you in our next video class.